Welcome to Machine Learning Lesson 4.2. In this lesson, we're going to cover our first machine learning model, which is linear regression, which honestly, it's a fancy word of saying line of best fit, which you may have covered in your math classes. In this, we're also going to cover the concept of distance, because it's going to help us to identify what is that line of best fit. So let's get to it. So in this slide, what we have is a set of data that matches temperatures to ice cream sales. And you can see in the chart, we have some data points kind of scattered around. They're not necessarily in a straight line, but you can kind of imagine that there is a line that somehow exists that kind of captures the essence of the data, which is, as temperature increases, so does the sale of ice cream. Obviously, when you're hot, you want to have something to cool you off. So what we're going to look to do with our machine learning model is, can we predict ice cream sales based off of temperature? So let's say that we were able to kind of draw that line of best fit, that linear regression through all these points. Well, now that we have that, we can use that line of best fit to make predictions. Again, are they actual values? No. The whole idea of this is that we're able to kind of predict, make an estimate as to what, our future sales could be. So we can see here in this first chart on the upper right hand, if the temperature was 21 degrees Celsius, we're looking at probably make about $480 in sales of ice cream. This is called interpolation because the point that we're looking to estimate somehow lies within our limits of our existing data points. Now let's look at this bottom chart. We can see here that we're looking to predict, well, what's going to happen when it's 29 degrees Celsius, very hot temperature. Well, our model will predict that it's about $740. This is called extrapolation because the point that we're looking to predict exists outside of our existing data points. That's okay. But this is something you have to be careful with when you start making predictive models, that sometimes the things you're going to look to predict kind of exist outside of our normal range. So for instance, if you had 50 degrees Celsius, our model is going to predict, something like maybe, over $1,000 in sales. But if you know anything about reality, 50 degrees Celsius, you're not going to have people around to actually eat the ice cream. It's too hot. But again, machine learning model doesn't necessarily pick that up. That's where us as human beings have to understand what our data is. So hopefully you kind of get a sense of what linear regression is. All it is just a line of best fit that we can use to predict future values. So how do we figure out this line of best fit? Well, in order to do this, we have to use the distance formula. And I'm going to show you in an interactive web page how we kind of use this distance formula. But again, the distance formula is just comparing the coordinates of 2 points and just find the distance. So let's go to the web page. Okay, so we can see here we got a bunch of points and they're kind of scattered around. These green and red lines kind of show the distance away from this line. Now this is just a straight up line. This is a y is equals x line. So our job here is to kind of minimize these distances. Well, let's do the intercept. So I can move the intercept down, up or down. So you can kind of see here, like if I did this, I moved the line down. It's kind of minimizing the distance between these points, but at the same time, it's increasing the distance between these points. And that's what this little kind of chart over here, or graph, whatever you want to call it, it's kind of showing you. So we have to kind of play around with this. Obviously, moving the intercept up and down doesn't seem to really reduce this part. So this is what we're looking to minimize. We're looking to minimize the distances between all the points. So the other thing we can do here is maybe we can play around with the slope. So let's move this up. Oh, wait a minute. Now we're getting somewhere. Notice how it decreased. So perhaps our points need to be more of on a straight line. Now, I will tell you just from a glance at this, these points are pretty scattered around. Trying to see. Again, at this point, it could be a game. The nice thing about this webpage, you could simply say, let's plot the best fit. And there we go. So we weren't too far off. I will say, though, this is an indication that, you know what, this data's, I don't want to say it's bad, but it's rough in that it's hard to kind of minimize the distance. They're just too scattered. So let's try to randomize. Matter of fact, let's pick some more points. Let's pick 10 points. Okay, so actually this turned out to be very nice. Just using the y is equal to, actually no, didn't use, oh, because this is still checked. I didn't want to do that. It cheated us out of trying it. Let's try it again. Okay, so we can see here, you know, these are the points. This is the existing line. And let's see if we could kind of make this even smaller. Okay, so you can see we could get it even smaller. Maybe we could change the slope around a little bit. Oh, that didn't work. Did this minimize it a little bit more? A little bit more. So I would say right now it looks like we're doing like a little game, trial and error. Obviously, when we go to programming, we're going to use the program to help us find that line of best fit. So let's go back to our presentation. Back to our first slide. All right, so in this lesson, we reviewed, you know, the concept of linear regression, which is just the line of best fit, and how the distance formula can be used to try to figure out what is that line of best fit by minimizing the distance between the existing points and our guess at the line of best fit. Thank you.